Hi there! I have a nice infinite sum problem for you, which is involving Fibonacci sequence, which is defined a0 and a1 is equal to 1, and we find the next term by adding up the previous two terms. It's standard. And we are supposed to find a bit weird looking sum. Previously on this channel, I solved the problem, and it was when n is greater or equal than 1, from 1 to infinity, n over 5 to the n. I will just link that video here. And this problem is actually somehow similar to that. And well, in that video, the way I solved this problem was, instead of 5 to the n, I said, let's solve n times x to the n. And well, you can just find this from just x to the n. You can just check that video. We know this is 1 over 1 minus x for when x is absolute value of x is less than 1, then you can differentiate both sides and multiply both sides by x, and you will see that you will get this thing. And in the end, you can just put x is equal to 1 over 5, which is just less than 1. Okay? So we solve that problem like this. And we are going to try to do the same logic here. Except, so in this question, this is n times x to the n. But so here we are going to say, let's solve. So n greater or equal than 1. Also here, if I put 0, it doesn't change. So let's just make it 0, because if I put n is equal to 0, this thing is 0. So it just gives me a 0. So we are trying to find n x to the n. So this is our goal. And so again, similarly, if I want n x to the n, it's enough if I just find x to the n and differentiate and multiply by x. So first, let's find what is, so this is our initial goal, this is our final goal, and then we will just put x is equal to 1 over 3. But first, we will try to find, let's find n greater or equal than 1, an x to the n. So this is actually corresponding to the generating function of Fibonacci sequence, which is actually quite easy to do, and we will also see how to do this. And generating functions, if you haven't heard about them, they're pretty useful. So we will make a demonstration now. So I'm given this recurrence relation, and I'm going to use that. So I need this thing. Okay, let's call this thing fx. The name is not so important, but I will just try to find fx in probably a rational form. Most of the generative functions look like rational form. So I have this stuff, and I'm just going to multiply all sides by x to the n, because I need an x to the n. Okay? So let's do that. So I have an plus 2 x to the n equals to an plus 1 x to the n plus, I'm also leaving some gaps because I will also do another thing now on this step. So I just multiply all sides by x to the n from our recurrence relation. And now, so I need the sum n from 0. So I'm just going to add all of the sides and start from 0. And greater or equal than 0. So this term is directly fx. But these ones are a bit shifted, right? So these two is not exactly fx, but I can find them in terms of fx. So this is the general logic of generating functions, okay? So now, well, I can just, first of all, I need to make this an, and then I can deal with the power of x. So it's always easier to deal with power of x. So I'm going to do this part. I will just put n is equal to n minus 2. So my sum will start from 2 an x to the n minus 2 equals to, and for this one I just need to put n is equal to n minus 1. So this will start from 1 an x to the n minus 1. And this is, let's directly write this fx, okay? And so for this one, I also want the powers x to the n. So this thing, n minus 2, if I multiply this by x squared, the power will be x to the n. So I will multiply it by x squared and also divide by x squared. If I divide and multiply by x squared, I will get this thing. So it's just equal. And similarly for this one, let's make this bit here. If I multiply this by x and divide by x, so this is the one I divided. And if I multiply this by x, I will just get this thing. Okay, cool. And now this two is more similar to the fx. And so what this one is lacking is the first two terms. If I put n is equal to 0, so this thing is just fx. If I put n is equal to 0, this is a0 x to the 0, which both of them is 1. So it doesn't have the term 1. And also when I put n is equal to 1, this is 1 times x. We also don't have an x. So this thing is equal to that. And this thing is equal to, so this is also almost fx. And it just doesn't have the first term we just found. It's just 1. Okay. And now, so let's also just distribute all of this. Or I will just do this in one step. Okay. So I'm just going to gather all of the terms. So I will just multiply this by 1 over x squared, this by 1 over x. And I will just get it into one fx parentheses. So let's think. So from this one, let's just gather them all on the left side. Okay. So this thing has 1 over x squared. This thing has 1 over x fx, so it's just minus 1 over x. I send it to the left side. And this one is just 1 fx, so this is minus 1. So this is all of the terms that has a fx. And let's send rest of the terms to the right side. So I have minus 1 over x squared, but on the other side it's just 1 over x squared. Similarly, this is just minus 1 over x, but it will be plus 1 over x. And I have minus 1 over x on this side. So I have minus 1 over x. So, well, these two will just be 0, so I'm just deleting it. Let's also delete this. And so, like I said in the beginning, I'm trying to find fx. So I'm just trying to isolate the fx. So first, I can just multiply both sides by x squared because this stuff is a bit annoying. So if I multiply both sides by by x squared, so this will be 1 minus x squared equal to 1. And then fx is just equal to 1 over 1 minus x squared. Perfect. So this was the first part of the problem. I expressed fx like a function. Okay, so this is a rational polynomial. Rational function. I'm not sure which one. Okay. So now I found fx. And so what did I say in the beginning? If I can find fx, then if I take derivative of this thing, okay, so let's write this thing. So I found fx, which is equal to n greater or equal than 0, an x to the n. And we found this as 1 over 1 minus x squared. And what do I need? An x to the n. So like I said in this logic, like this was a question that was solved similarly. So I just need to differentiate both sides. If I differentiate both sides with respect to x, okay, so f prime x is equal to n greater or equal than 0. So this will just be this is x is the variable here, okay. So this will be, it's just power rule, n x to the n minus 1, n x to the n minus 1 equals to, and I'm just going to differentiate this side. This is derivative of division. So this is first one's derivative times this minus this one times this one's derivative, which will be minus 1 minus 2x, but it will be minus plus. So this is just 1 plus 2x over 1 minus x squared. And I have, of course, the this thing squared. Okay, perfect. And again, so I need x to the n, but here I have n minus 1. So I can just multiply both sides by x. So this is multiplied and this is multiplied. Okay, and that's all. So again, I'm just going back to my question. If I put x is equal to 1 over 3, this is going to be convergent. Okay, so I'm just going to put 3. Also, here I need to be a bit careful. So I'm trying to put x is equal to 1 over 3. But do I actually know this will be convergent? So let's check on this one. When this will be convergent? Well, this is almost like 1 over 1 minus x, right? And I know that, so this is in the form of 1 over 1 minus something. X plus x squared. And so this thing will just be convergent if this thing is less than 1. Absolute value of this thing is just less than 1. And if I put x is equal to 1 over 3, so 1 over 3 plus 1 over 9 is of course less than 1. So there is no problem. Okay, so I can just put x is equal to 1 over 3. And when I take derivative, the radius of convergence doesn't change. So I can still put 1 over 3. It's why I check this one. I don't want to check this one. So when I put n is equal to, for x is equal to 1 over 3, I'm going to get n greater or equal than 0. It doesn't matter, it's 1 or 0, both same. N, a to the n, so I just put x is equal to 1 over 3. This will be 3 to the n equals to, so 1 over 3. This will be just 2 over 3, 5 over 3. Over, so this will be 1 minus 1 over 3 minus 1 over 9. This is just boring algebra part. 5 over 9. So I can just flip it. So let's write this normal, 5 over 3. So this will be 5 over 9, 9 over 5. And this thing squared. If there is no mistake, so these 3 will cancel. This is canceling. And I get 9 over 5. Let me check. I think, yeah, this is the correct answer. So the answer is 9 over 5, and that's the end of it.